In this lesson, we're going to talk about the derivatives of the inverse trig functions. It is unfortunately 6 more formulas to memorize for derivatives. The reason we don't learn them at the beginning of the year with the rest of the derivative rules is because these ones don't come up too often on the AP test, and because of that, I save them kind of for right before the AP test so that they're fresh in your memory. And also, it is kind of just a lot to memorize. We don't use them too often. On the AP test, they might show up like one time. One of them might show up one time. And so, like I said, they're just not very prevalent on the AP test, which is why I don't emphasize them as much. However, here is what they are so that you guys can learn about them and figure out how to use them so that as you're reviewing and studying for the AP test, when you come across a problem that requires a trig derivative, you're able to do it. Sorry, an inverse trig derivative. Just as a general reminder, inverse functions are reflections across the line y equals x, and so when we find inverse trig functions, it's the same thing, where we reflect them across those lines. So for example, and this is a notational thing that I want you guys to gain from this page, but here is the sine function. So the inverse of the sine function looks like this, and notice that the bolded part of it is the part we restrict, because it actually is not a function if you keep the entire thing. So we just keep this little bolded piece of it right here in the middle, and then everything else we get rid of so that it does actually create a function. But that's not necessarily something that's super prevalent, what we need to know for this. The main reason I wanted you guys to see this page is because I want you to notice that when you take the inverse, so switching x and y, and then to isolate y, you would do sine inverse of x equals y. So that's where we get this from. And I just wanted to mention this as well. So I want you to make sure that you are aware that those two things are the same. So sine inverse of x is the same thing as arc sine of x. So when you see this, you just need to think sine inverse. And the reason that we sometimes use arc sine instead of this way of writing it is to distinguish between sine inverse of x and 1 over sine of x, because some people get confused and think that sine inverse means to take the reciprocal, but it does not actually. So a couple of examples. It says to evaluate arc sine or sine inverse of negative 1/2. So remember that negative sine is in the first and fourth quadrant, so we're only looking here. So if I want sine to be negative, I'm looking down here in the fourth quadrant. And if I want sine, which is my y value, to be 1/2, then I should be looking at this angle right here, where this is negative 1/2, this is radical 3 over 2, and this is 1 from the unit circle. And this angle happens to be, it's my over 6 angle, and it's right before 12 pi over 6. So this one is 11 pi over 6. So sine inverse of negative 1/2 is 11 pi over 6. Cosine inverse of 0, so finding all the places where cosine is equal to 0. Remember that cosine is restricted to the first and second quadrant. And cosine is equal to 0 only one time in that quadrant, and that's right here at pi over 2. So cosine inverse of 0 is equal to pi over 2. Excuse me. And then there's these ones where it says to evaluate these. I like to draw pictures with these ones because in this case I actually don't need the angle. I just need what the angle could be and then to evaluate something else. So what I mean by that is if I know arctangent, which is tangent inverse, I'm being taken of 3 over 4, I can actually set up a little triangle. Oops. I can actually set up a little triangle where tangent is opposite over adjacent. So if I know that tangent of some angle is equal to 3 over 4, I don't even need to really evaluate the angle, I just want to know what sine of that angle is equal to. So notice in this triangle I have a 3, 4, 5 right triangle. So arctangent of 3 over 4, in this case, is equal to theta. So then sine of theta is equal to the opposite side over the hypotenuse. So opposite is 3, hypotenuse is 5. So notice that you're able to, without actually solving for what theta is equal to, you're able to evaluate these problems without that knowledge. In this one, I have arc cosine, cosine inverse. So again, I'll draw my little triangle. I know that cosine inverse of radical 2 over 2 would be this being radical 2 over 2. Sorry, cosine is adjacent. Radical 2 over 2. And then this being 1, that makes this also radical 2 over 2. And I know that because this is a 45, 45, 90 right triangle. So if I said, all right, cosine inverse of radical 2 over 2, radical 2 over 2 over 1 is theta, then I want to know what tangent of theta is equal to. So opposite is radical 2 over 2, adjacent radical 2 over 2, and I divide those and I get 1. So tangent of theta would be equal to 1. Now these are where the formulas actually come from. I'm only going to show you one of them, but you could technically do this for all of them and figure out where these formulas came from. So essentially it says to, up here at the top, when we take derivatives of inverse trig functions, to actually find the derivative of the inverse, which you see here, derivative of sine inverse of x. So I'm actually going to write this as sine inverse of x is equal to y. And then when I'm trying to find, I'm sorry, not that way, the other way around. My bad. Let's talk about this picture first and then we'll come back to it. Sine inverse of x is equal to y, they have written here, sine inverse of x is equal to y. If I'm looking for the original function, or not the original function, but a function without a sine inverse in it, to actually find the derivative of sine inverse, I could move the sine over to this side and get that sine of y is equal to x, like we see here. So if I set up a triangle with that information, sine of some angle is equal to x. And I know that sine is opposite over hypotenuse, so that will be x over 1. So the opposite side is x, the hypotenuse is 1. And then to find the remaining side, which is the square root of 1 minus x squared, we could do the Pythagorean theorem. So if you did a squared plus b squared equals c squared, if you solved for this missing side, you would get the square root of 1 minus x squared. So it says, now that we have this little triangle set up, it says since sine of y equals x, we can take the derivative of both sides. So essentially we're looking at this equation, and taking the derivative of both sides. So if I'm going to take the derivative of sine is cosine. The derivative of its cosine of y. The derivative of the inside, the y, is dy dx. So this is like an implicit differentiation thing. The derivative of x is just 1. So this is the derivative of that function using implicit differentiation. And then we solve for dy dx. So to do that, we would divide both sides by cosine of y. So you get 1 over cosine of y equals the derivative, dy dx. And last but not least, we can replace cosine of y with what it equals from this picture. So cosine of y would be adjacent over hypotenuse, which is the square root of 1 minus x squared over 1. And that's how we get this equation, which is the derivative of the inverse sine function. So sine inverse of x has a derivative of 1 over the square root of 1 minus x squared. Again, that's the only one I'm going to show you. All the rest of them can be figured out the same way, but here are the 6 derivatives of trig functions. So if you want to go ahead and pause your computer really quick, or pause the video and go ahead and write those down. The one we just looked at was this one. Notice that all of these have u's, by the way, because it's not typical that they would just ask it with an x in there. They typically ask it with another function inside. So they're just showing you when you have another function inside, here's how it changes it. So if you want to take a minute and pause that, go for it. We're going to get started on the first example. For part A, it says to find the derivative of sine inverse of 4x. So here's my arc sine. The derivative is u prime, and u is the inside. So 4x is the inside function. The derivative of 4x is just 4. So y prime is equal to 4 over, and then it's the square root of 1 minus u squared. So the square root of 1 minus, and then again my u, which is 4x, quantity squared. So you can leave it like that, or you can simplify. That's 4 over the square root of 1 minus 16 squared. And I'm going to leave it like that. For the second one, for B, it says tangent inverse of x cubed. Okay, tangent inverse has its derivative right here. It says it's u prime over 1 plus u squared. So my u in this case is x cubed. So y prime is equal to the derivative of this, which is 3x squared, over 1 plus u squared. So x cubed squared, which is x cubed squared. If I want to simplify that, that would be 3x squared over 1 plus x to the 6th. Final answer. All right, the next one has a little bit more of an intense chain rule, so it has an inside, a middle, and an outside. So let's deal with the outside first and their derivative, and then we'll go back to the middle. So y prime is equal to, the derivative of the outside would be the middle cubed. So that's 3 times the middle, here, let me write this with a thinner pen. 3 times the middle squared times the derivative of cosine inverse of x over 2. So here we have the derivative of cosine inverse. So it's negative u prime. So negative, and then remember my u is in here. This is my u in here. So the derivative of that is 1/2. So negative u prime would be negative 1/2 over the square root of 1 minus u squared. So the square root of 1 minus, and then my u is x over 2 squared. And again, there are ways you can simplify that, but I'm not going to take the time right now to do so. And then the last one, it's the derivative using the product rule. And then this is a normal derivative over here. I don't even know if you guys can see this, but the derivative here using the product rule with x times sine inverse of x. And then this one is just the square root of 1 minus x squared. So I think we've done enough of the examples, though, that you would go back to be able to do those ones. So, like I said, this is not the most heavily weighted topic on the AP test. In fact, it might come up one time on the entire AP test, and of the one time it comes up, it might come up with one of these. So these are good to have in your notes for when you're practicing for the AP test to get to use them, but it's not the most important thing I need you to have memorized for the test. All right, that's the end of the notes for today.